All right, I think we have enough people. Let's see. Share. There you go. All right. Shing, are we recording?
Yeah, I've started recording.
Okay, thank you. All right, so I'll give a quick overview of what our current priorities are and where we're at with regard to these things. One of the things we said a few months ago, Andrew, you might have missed this, and anyone who's new may not know about this, was we wanted to do a demo, as we wanted to keep a demo as one of our milestones. And the reason for choosing a demo as the milestone is it forces us to um, work on the end-to-end aspect, or every part of the architecture, and have one use case working well. It forces us to work on the end-to-end workflow. The demo we defined it as where is that? Yeah. So for the demo, we defined our requirements as a cozy system, which would be able to create a bucket, grant access for that bucket to a workload, um, and 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 take, or grant access would be creating a token for that workload, and provisioning that bucket into a pod is providing that token to the workload. So we added a few more constraints in the demo. We said whatever we show in the demo will also be, it won't be a smoke and mirrors kind of demo. It'll be a demo where the code will be tested. There'll be test cases for it. There'll be documentation, and it'll be as close to shippable code as possible. And I'm happy to say we've made a lot of progress on this front. There was some uncertainty until last week or so, because we were still changing one of our gRPC APIs, but that's been resolved. And so we should be on track to show you a demo very, very soon. I'll have to figure out the progress of the individual tasks, probably during this meeting or after. So that was one of our milestones. The other milestone we had was the API review. So we got started on the API review, and a really interesting question came up from the API reviewer. I have to go back a few slides for that. So let's see here. Yeah. So the question that came up was, there are some scenarios where we might possibly envision mutating a bucket. Say, for instance, you want to make a bucket go from private to public, or say you want to make a bucket to have a configuration set on it, like locked objects, so object locking enabled. Um, so the so a question came up if bucket mutation is something we even want to support in the first place. And
and we discussed the two that you just mentioned specifically and decided for those probably not, right?
yeah,
But that doesn't rule out that something that's eventually will need to be mutable.
right. So since there are new people and old people that haven't participated in this discussion, I wanted to take them through this again.
Yeah.
And um, define the addition one more time. Yeah. So for bucket mutation, just in practice, um, this is a very or let me put it this way. So um, once the bucket is created through the cozy system, we expect that creation to be automatic, in the sense that a bucket request is made and the bucket creation happens for the workload. And when the workload goes down, cozy is really designed to tear down that bucket once it's done. In such a scenario, since bucket is created, uh, it's not always the case, but since bucket is created for the workload, bucket mutation is not a high priority. I'm trying to see the best way to put it. Um, is not a, is not, it would almost be an anti-pattern. That's what I want to say. Now, like Ben said, there might be something in the future where we might see that we need to support bucket mutation, but with the experience that I've had in this space, seeing how Minayo's customers used buckets, it's almost never that bucket properties are changed. Um, so even in practice, we see that bucket mutation is not something that is uh, 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 generally requested or seen as a deal breaker in terms of how people use buckets.
And just to add to that, like you're talking about maybe a use case where humans are using these things. What we're designing with Cozy goes a step further and says this interface is designed for automated consumption. And in an automated context, it seems even less likely that people would build in bucket mutations to their automation schemes. Because if they weren't happy with whatever feature was set on the bucket, they would just go back to the beginning and change their whole automation mechanism to make a different kind of bucket, right?
So can I add a couple of things? This is Andrew, sorry, in case that's not obvious. So and by the way, I was completely in line with that, but I would say that there are two considerations that have bothered me along the way where I feel like we're not really directly aligning with this.
Mm-hmm.
One of them is, we had a lot of discussion, and I don't even remember entirely where we landed, but on the control over who cleans up a bucket when you deallocate the original request for it. And this was a whole greenfield versus brownfield, but I do feel like one of the things we definitely had was a convoluted, if not non-existent, clear ownership of bucket lifecycle. And I think that was one of the things that the API reviewer responded to, was that we were not crisp about how ownership works. And now, I think he also asserted that ownership then becomes also the point of control where you could mutate the bucket. And we can argue that we don't think bucket mutation is something that we want, although I would point out that if bucket mutation is not something that we want, then bucket properties should be only minimally exposed in the claim side object.
Right.
But we decided to make the whole public or private thing available there instead of hidden into the class. And so we kind of weaken that argument, because it seems perfectly reasonable that somebody might want to change that status over time and expect that they could change the claim object to do so.
It's not too late to fix that mistake.
Yeah, that's one. And number two is talking about ownership. So there's two sorts of ownership that you mentioned. One is ownership over deletion. Another is ownership over changes. So in case of deletion, we were talking about which one of the buckets, if there were multiple clones of a bucket when it's being shared across namespaces, which one of the buckets would be would trigger the relation of the actual backend bucket. And I think we reached a conclusion on that, where we said we would designate one of the buckets as the owner bucket, or we had a name for it. I have to look back and tell you. But when that bucket is deleted, we pull the rug out from underneath all the other buckets as well. That was the deletion part. The ownership over deletion is different from ownership over mutation, where what Tim raised was, if the user is responsible for creating the bucket, shouldn't they also be able to mutate the bucket? And if that's the case, how do we allow them to do that? Or that's what I've written here, written down here as self-service. So that's the ownership question that came from Tim. It's all assuming that bucket mutation itself is something we should support.
Right. So I guess what I would point out is there's ownership. There's really two questions here. One is the mechanism, and the other is what it means to be an owner. And for example, one of the things that Tim mentioned to us that, and I'm going to apologize for not maybe being super on top of the latest design, but one of his suggestions was that brownfield and greenfield maybe should even look different. That as a subscriber, as the on the claim side, that what you're putting together should be very clear that this is brownfield, in which case maybe mutation isn't even possible, or it's greenfield, in which case why not allow mutation? If you're the sole owner of a bucket, what's really the argument against allowing it? And so that could align up completely with delete permission too. You can only delete a bucket if you're the only one accessing it.
That was the path we started to go down when we were trying to design a way to support mutation. It was basically along those lines. Like there would be a flag that says this is the guy that is the owner. We were calling it like an update policy, which could
Bucket
be true or
mutation
false.
policy.
Yeah, but something like that. And it could be distinct from the deletion policy or the same as the deletion policy. We could rename the field. That doesn't matter. But yeah, some field on the non-namespaced object that says this one is the original. This is the one that can make changes and can do deletions, and anything else is just a pale shadow of it and can access it, but the controller won't respect changes through those replicated handles of that bucket. But even that turned out to be kind of gross. And so I thought that the question we were facing was like, should we sidestep all of this and just not allow mutations? Because if the answer is we really want mutations, then I think we have to look at that design again.
Well,
yeah. So the other thing I would say that Tim was suggesting, which is to me a fairly novel approach to this and something I hadn't even considered, is he was saying if you want to allow mutation, then the key here is that you want that mutation at the workload level, not at the administration level, right? Because then you would have to go to the administrator anytime you want something changed. And so the implication was that maybe there shouldn't even be a sort of content side non-namespaced object here. That the claim side, that the claim piece and the content piece could either be literally in the same resource as a spec versus status kind of thing, or two namespaced resources. And so the idea of you having control means you directly have control. So you delete that content object out of your namespace, it deletes the bucket.
Yeah, like cluster role binding and role binding. I remember this. But again, this is all assuming that, yeah, just to set the context again, assuming that mutation is something that's important. Yeah, we discussed this, and we have two other approaches as well. Yeah, in based on in what Tim was saying about having namespaced version of it and then the cluster version of it. There are still a lot of unanswered questions, and I don't know if we should go down that route just yet. He was saying this from the context of a DNS policy, I believe, or load balancer policy that was being applied internally in Google, where a team could specify a policy that that was specific just for their needs, and the admin would be able to specify a default policy for the entire setup. Is that right? Am I getting that right?
Yeah, I mean, I think the broader point that Tim was making is he feels like there have been some lessons learned and mistakes made in earlier incarnations of some of these structures, like particularly PV/PVC. And that the big lesson learned is that users need more control, more self-service control. over configuration. And that by sort of shoving everything into non-namespaced objects, we kind of make that control very difficult to provide. And he's actually arguing for this model where, you know, you move much more of control, and then even the resulting resources into the namespace as the mechanism of that. And you can still apply policy, and then you can have different access control rules that allow you to modify the spec but not the status, which is sort of a default.
I don't understand how that's different than the direction we were going, because the theory would have been that, like, let's say the shared versus private attribute was something that you wanted to be mutable. You would have a field on the bucket request that specified what you wanted to request, and then it would be reflected into the bucket object, the non-namespaced object, and there would be a policy on the non-namespaced object that would say whether changes to the namespaced object should be propagated or not. And if it said yes, because it was the so-called greenfield case, then you could change it, and some controller would notice that change and copy it into the bucket object, and then some cozy driver would go, you know, do the work to make that happen and then reflect it in the status, and you know, it would be self-service only if the policy was set. The whole problem was if you got 2 or 3 different objects all pointing to the same actual bucket, what is your source of truth, right? You can't have different people.
Why he was suggesting you move that into the namespace, and that becomes the source of truth. And so everybody else has a reference to a different namespaced item. And you're, by definition, the only one, because it lives in that namespace. That is where the source of truth is.
So you mean when I want the brownfield case, or when I want to share a bucket with someone in another namespace, they have a pointer back to my namespaced object? Yes. From their namespaced object?
Yeah, that was his proposal, or, you know, his thought.
Like having pointers across namespaces is something I haven't seen before. That's a new pattern.
Yep, same, was new to me as well. I mean, Saad, am I capturing, you think, the conversation properly?
Yeah, I think those were the two takeaways I had from the conversation with him. One was around, you know, if we're going to allow mutation, how is access control going to work, and the whole having application developers have control versus requesting, you know, permissions from some cluster admin. And the second was this approach of allowing that by shifting these objects into the namespace and making it more application centric rather than
well,
cluster centric.
Hold on. So we always say that, like, requesting permission from an admin is how you make changes to non-namespaced objects, but that, I mean, I've always assumed that we would eventually make a controller that does these things for you and make the default behavior something sane. Like, you know, for something that already exists, for example, like snapshots. You know, snapshots have a deletion policy that gets stamped on it by the snapshot class when you create it, and you get whatever the snapshot class says. And then if you want to change it, you can't do that directly. If
you can't do that at all, right?
Well, you'd have to ask an admin, right?
Yeah, exactly.
An admin can do it, but if you want to perform an import of an existing snapshot or like a brownfield clone of a snapshot, you also need an admin to do that. Today you do, but there's nothing to stop us from writing the snapshot cloning controller that allows you to, like, make a request to get a copy of a snapshot, or make and the controller could change the deletion policy as part of that operation, or give you a way to make changes to, I mean, it's just a matter of writing another controller to make these changes, and then that controller becomes your enforcement point. You don't want to always have humans involved. It's sort of a fallback while we don't have a controller. But I guess I see the same thing with buckets here.
Is then you could, well, yeah.
My argument would be, like, you address the greenfield case by saying ones that are created by, you know, through the greenfield path where I create a bucket request and it gets provisioned, those get they default to the deletion policy and the mutation policy, where if you change your copy of the object, those changes will be reflected. the only way to get the brownfield copies is today, based on the existing design, is to have an administrator do it. But you would, I assume very soon after we get this working, have a controller that does this work for you, and it would set the policies to the correct values for brownfield as part of its operation. And then if you needed to ever change those for whatever reason, like swap ownership with another guy, you'd have a controller that would perform that operation for you. And in the long run, yeah, you would never need a human. It's just that you have to have the control. And so we make it sort of the non-namespaced, or, you know, out of the ordinary user's vision, so that a controller or a human has to do it. But that doesn't mean it always has to be a human. It's just a controller we haven't written yet, I think.
Yeah. So one thing, it'll be great if Tim can join us on the call. It's really, I mean, this conversation should be either on GitHub or on the calls.
I actually thought Tim was going to be here today. I'm not sure why he's not. He probably got pulled off on something else.
Yeah, because yeah, I actually asked him to over email, because it'll be good if everyone was present during this. Again, I want to set the context. Do we want to support mutation?
I think we wouldn't want to do the heavy lifting until we had a compelling use case for why.
Right.
We don't yet, but it seems likely that eventually we will. So I don't think we get to dodge this bullet. It's just a question
Can
of
we
when.
can we be a little bit more crisp on what mutation means, specifically what type of mutation and we would allow?
So what we were talking about is there was a, I don't know, Sid, you had a slide that listed like a whole bunch of potential first class features at one point. And what we had talked about earlier on was like, all of these things can be, you know, opaque parameters for now at the cozy RPC layer. You know, it's just opaque parameters until like multiple vendors get together and say, we want to support a common version of feature X. And then we would promote that to like a top level field with a crisp definition on like what it meant, you know, when it was, you know, with all the things you would want out of a cozy spec for that particular feature. And then once you did that, then it would become a first class object on the Kubernetes side too. And then at that point, the question is, well, if it's reflected in the object and somebody changes it, should that change get reflected back into, you know, the cozy driver by some controller? And the logical answer is, you know, if you go through all these things, yeah, probably. Or I mean, maybe there's some that would be clear it's an immutable field that you set once and it can't change, but there were a few examples in this list here that seemed like maybe you'd want to change them. You know?
Yeah. So actually, I looked through these features on all three cloud providers. All three have every single feature. So initially, I thought GCS doesn't have all of them, but it has all of them. I couldn't find one that was on any one cloud that wasn't on the others. So yeah, these are just the parameters.
The question is, are the various implementations common enough that you could write a cozy spec that explains the common behavior you expect when you ask for these things?
I wouldn't think it would apply also to on-prem providers, as it is right now. But coming back to what kind of things can be changed, or what configurations exist that could possibly need changing. Actually, now that I think about it, I don't see any of them here that would be changed by a user. Like a user wouldn't make the decision to.
So I think the one that Tim was calling out was the anonymous access.
Yeah, I was the one who gave him that use case. So what the exact use case I told him was, let's say this bucket is going to serve as a website, a static website for whatever application. Until the website is ready, or all the different pages are filled in, you want to keep it private. But when you're ready to launch it, you make it public. That was kind of the use case that I explained. However, I don't know how much that applies to automated provisioning of buckets, because in that case, a website is not being consumed by a workload, it's being consumed by a user. User would have to upload files into the S3 bucket. And
But why, sorry for jumping, but why do you think cores, lifecycle logging, all of these are not user configurations? I believe that the workload owner is typically the one configuring these, not an admin of a platform.
So we have to go back to understanding, or what we decided would be a user versus what we decided would be an admin. If we define the user as an application developer who wants to consume a bucket, then they're not going to worry about these infrastructure level concerns here. Things like, do we enable logging on the bucket side, access logging, or do we enable versioning on the objects? Those are concerns that would be addressed by the infrastructure admin, whoever is responsible for ensuring that there is some data durability and security and stuff like that over the system.
But unless the features result in an observable change from the workload's perspective, then they don't matter to Kubernetes, right?
Right.
Because the job of Kubernetes is to take your request and then satisfy it and then signal to the workload that some additional capability is present. But if the workload doesn't care or can't know, there's no point in making anything other than an opaque parameter.
Right.
But for this anonymous access, is our argument that we will allow mutation, but the mutation has to go through a cluster admin?
Or I think anonymous access shouldn't be a first class field
Right, and I agree with that. I think it should be yet another opaque field. If you were to take that example and say, yes, it is a first class field, yes, you can change it, then the idea would be, if your copy of the bucket request was bound to a bucket that had the mutation policy set to true, then when you changed your bucket requests object anonymous access from false to true or whatever, the controller would respect that. But if the policy on your bucket object was set to false, the mutation policy was set to false, then you changed it, nothing would happen. You would just get like an event saying nothing happened.
And so basically you kind of get both by default, the cluster admin gets to decide everything if they set mutation to false, and they can optionally choose to allow the application developer to mutate by setting a field. And if they set it, then this type of property could be mutated by the
and
application
it would
developer.
work just like deletion policies work today. If you set the deletion policy to retain and
Right.
someone tries to delete it, nothing happens.
Mhm.
Yeah. So I think one of the most important things that I've wanted to address the last few days is, and it's hard to get Tim's time, is we have to get him up to speed on the decisions that we've made along the way. I think actually, even more importantly, the KEP doesn't do a good enough job of explaining it well, and that is my responsibility. So I'm actually working with Jeff to improve on that. But I would still, if any of you can also request Tim to join us on our calls, that'll make a big difference. Saad or Andrew or whoever from Google.
Yeah, we can follow up with him. I was under the same impression that he was going to join today, so he must have been pulled in somewhere. We can see if he can join next week.
Okay. If that's the case, I think for now we should stick with how we've been designing it, unless we have a like Ben was suggesting, unless we have a compelling use case why bucket mutation is important.
So just be aware that Tim's position right now is that he will not recommend the API. So we're going to have to either make strong statements or fix something.
Yeah, no, of course. Again, Tim is just getting into this now. he's probably looked at this a few times only. And so the reason, I mean, I would be more concerned if, he understood all of the decisions we made and then said something needs to be changed. I don't think he spent enough time yet, just because of how much is there to look at, um, um, for us to be actually concerned just yet. Again, I think the problem is he hasn't been fully informed, and one of the reasons for that is, of course, the KEP. The other is, we should follow up with him and have him join a few of our calls. And I think that'll sort it out.
But I think one of the things that we can achieve without Tim is an opinion on, do we ignore mutable things for now, or do we want to tackle it for now? Because I think we can reasonably say, no, we're just going to punt on it and design an interface that doesn't allow
what I can say that Tim will say is, if we decide to punt on it now, we at least have to have a view on how it will be added later.
So we can't dodge the bullet.
No, but wait, hold on. So as of right now, I still can't see a strong use case where a user would have to mutate the bucket. I'm not even saying we punt on it. I'm saying we design it this way, where the user does not change these things.
So then we should be ready with a number of real world scenarios and explain how none of them require this, or to the extent that bucket mutation is required, why it makes sense to do it outside of Kubernetes.
Yeah, I think that'll be easy to do, to be honest, because again, these concerns, all of these concerns, are not application developer concerns.
Yeah. I think you can make a strong argument for all those bits you can twiddle. They're things that you should know at bucket creation time. Either you want the feature on or you want it off. If you set it one way and you change your mind, it's totally reasonable to go back to the beginning and create a new bucket. Because this is we're designing automation.
Data. And what about the data? I mean, the bucket is not just.
I'm presuming that the types of buckets we're dealing with are buckets that are getting automatically created, automatically destroyed. That they're not typically long-lived things. That the whole point of Cozy is we're automating the creation and destruction and usage of the buckets, because the buckets serve some function in a larger workflow. Like, yes, you have your big giant buckets that live forever, and those have a different set of, I don't know, aspects to them.
They might not live forever. They might live as long as your workload, but the workload is living, right? A live workload, and then how do you mutate any of these configurations? That's the only question. So you might say, yeah, let's bypass Kubernetes there. It's fine.
Yeah, I guess what I'm talking about is like in a development workflow where like you're writing code to do something in Kubernetes. Like you're going to design it one way with a set of options for your bucket creation, and if you decide that you got it wrong, or you want to develop version 2 that takes advantage of some feature that version 1 didn't contain, like you're going to rewrite your code, push out a new version, start a new set of pods and new set of everything, and go on with version 2. And like it seems reasonable to me to say that like at the moment you create the bucket, what that version of the workflow wanted, so it can request what it needs. And then if you change your mind, you're going to write version 3 and start over again. And like, yeah, if you have some long running thing, you might need to twiddle things out of scope. But generally speaking, we're talking about automation, not something that a human is involved in.
Right, and also there's a difference between PVs and bucket requests here. In case of PVCs, nothing is configurable from the PVC itself. In our case, that's not true. The user still can choose these options during the creation time. With PVCs, you're completely blocked off from being able to do that.
It's all in the bucket class, right? Isn't that just like PVC?
Yeah. Everything you said is in the class, and you know it up front, and
right.
you pick what you want.
No, in storage class, you can't even configure, Jeff. It's
Yes,
a
and
best thing
right.
you have is a set of opaque parameters.
Yeah, but you can pick from a menu, and if you don't like the menu, you can change it. But yes, you with an administrator's help, you can change the menu. But yeah, you know what things matter to you, and you can look at the storage class and say, yep, it has the things that matter to me. I'm going to use it, and I'm going to go. And then once your PVC is created, yeah, you can't really change anything other than the size. And as we all know, resize turned out to be way harder than anyone expected.
Ben, I believe you can change the claim policy on a PV also.
Yeah, that you can change. Yes.
not without an administrator's help or a controller that acting on behalf of the administrator.
Yeah, because that's the
Well, I know a user
namespace
can't, but
object. Yeah.
what was that, Shing?
Yeah, it's because that's the non-namespaced object, right? So that's on the PV
Yes.
itself. Yes.
So an admin can change reclaim policy on a PV today, right?
Yes.
Yeah. And so that's an interesting example, because if we have the retention policy wrong in the bucket class, it's just a human error. And the bucket's been populated now. And the error is that it was set to delete. We don't have a way in Cozy to change it to, to save it. And so once teardown starts in the B, that bucket, physical backend bucket will go away when that wasn't desired. It was just a human error.
But I mean, you have a default, which is, it's going to do what the storage class says it's going to do. So like, by default, most of the buckets you create through automation, you want to destroy through automation. The reason the administrator can change the reclaim policy on PVs is because every now and then, you change your mind and you say, oh, wait, this is a special one. I want to disconnect it from the regular PV deletion process because I want to do something special with it. And but that's not a daily operation. That's a decision you make about a specific volume.
Right. But if we don't allow any mutation, then that is, even though it's a rare occurrence, we can't do it in Cozy.
Why would we not allow you to change the deletion policy? I mean, you can do it for snapshots. You can do it for PVs. I think.
Hey guys, Tim just joined, so if you guys want to pick his brain.
Welcome.
I apologize for being late. Somehow it didn't. I don't know if I forgot to put it on my calendar or something, but I apologize.
No, it's all right. So Tim, so we were talking about bucket mutation and ownership and self-service. I think those were some of the main questions you raised in the API review, and so we discussed this last week after you raised those questions. And one of the things the result of that discussion was, do we even need to support bucket mutation? That's where we ended up, questioning if this is even an important feature. I know
it's a fair question, and certainly not supporting any form of mutation would make it easier. The question is really, can you get away with that?
Yeah. Right. Yeah. So that's literally what we were talking about just now. So, I got an exhaustive list of parameters on the bucket itself. Other than these, you could have parameters on the driver, but that wouldn't apply to a bucket mutation workflow. So GCS has the rest of the fields. I figured out later on, rest of the features, I mean. So does Azure, but this is an exhaustive list of features as listed inside of the AWS docs, and also at Minayo we support these.
Right. So, yes, definitely GCS supports things like lifecycle. It's just not
it has a different name.
Yeah, and it's not a trivial API. It's not like a bool flag or something, right? There's actually like a grammar.
Yeah. I think you can set 2 or 3 different kinds of policies. Anyway, so coming back to this, on the left hand side we have the list of features, and we define a user to be someone who is an application developer that wants to consume a bucket for their workload. All of the concerns here that are listed here are not application developer or user level concerns. These are infrastructure level concerns.
Is that right? I mean, let me be devil's advocate, right? As an application developer, I want to make sure that even if my app gets compromised, you can't delete data from my bucket because it's really important data. So I want to be able to set the retention policy, right? I'm going to put a 10-year retention policy on every object. And
but you know that up front when you create the bucket.
yeah, I mean, not always. Like you write your app, you create your bucket, you're doing your thing, and then you get a security audit and you go, oh, you know, we should probably be adding this thing. Or cloud provider launches a new feature and you go, ooh, that's useful. I want to turn that on, right? But I'm saying
then you change your automation workflow to start requesting buckets with the new feature, and any existing buckets you just have to go fix. But the whole point of Cozy is we're creating and deleting buckets in an automated way, and you have to change your workflow to consume the new feature.
So that's an answer. I'm just trying to advocate, or trying to take the position of making sure that whatever answer you propose holds water to somebody who would potentially use this. I'm saying I've got workloads that I would probably use this for, and we've been through this process of, oh, maybe we should turn on the lifecycle feature. We didn't realize it was there before, but maybe we should turn it on.
I think the argument is, for most of these, you should know at creation time whether you want them or not. And if it's something new, you have to change your workflow anyways to start taking advantage of them. And yeah, if you have a bunch of existing buckets, there is a problem to be solved. But that's not the common case. The common case is you know what you want when you create the bucket.
I'm not here, so I'm certainly not here to argue with your product market fit, right? That is not my goal. My goal is really just to hold your feet to the fire and make sure that the things that the questions that I have that are appropriately designed out or accommodated, right? If you say that that's just not what this does and this API isn't for that, okay.
Yeah, I think that's the perspective, because the way, you know, if you're going to automate the creation of buckets per workload, you're not really looking at you know, the manual steps being involved at all, where an admin goes and you know, configures whatever for the bucket. We don't. Everything you want to know is, or the bucket is really designed for that workload to consume. So when the workload goes away, we see the bucket as something that also goes away. That's how Cozy should be consumed. Is where we're coming from, in terms of best practices, I would say.
Just adding, I think that it's like immutability is a very, you know, it's a feature that simplifies a lot of things for us and for users as well in some cases, but on some other ways, I think it really complicates the life of a field. You know, somebody's who's actually supporting this. So I tend to, you know, I agree that it simplifies, but it doesn't solve the problem for others who really support that after that gets deployed. So
we have to decide if our ambitions are to be a full bucket management engine or just a way to easily consume buckets in an automated way inside Kubernetes, right? You could have the much more ambitious goal of being the bucket management tool for the whole world, which it sounds like is what you're suggesting.
Well, I think, I mean,
it's through Cozy, right? In that view.
I don't think the you know, the gap is very different. Like it's mainly about, you know, these capabilities that we're looking at right here that you find in cloud platforms as a configuration, and we are suggesting let's keep it out of the loop for Kubernetes, since it's like not part of an automated workload deployment.
I find it instructive to look at how we handle volumes and how Kubernetes knows almost nothing about the detailed workings of storage. It just knows about its block or file system. It's got a size, it's got a few access modes, and maybe you can take snapshots, and that's it. And like that's good enough for the vast majority of what Kubernetes does with volumes. And then all of the special options, you just go to the storage controller to configure them. Kubernetes doesn't get in the way. It's a model that works well.
It is, though.
Right?
Sorry, go ahead.
I was just saying, like, retention policy can change it for the PV. So, but here we are saying that is not allowed. The bucket, I think that seems to be a problem.
I think you should be able to change the retention policy. That seems like a nitpick.
Well, let's be clear. Retention policy on a volume is about, do you leave the underlying volume around when the Kubernetes volume is removed? Versus retention policy on a bucket is like, is the API operation to delete a blob from the bucket allowed? Right? They're very different.
That's not what I thought.
No.
Oh, no. Oh, when I see GCS retention policy, what I see is, even if a user with a valid credential tried to delete a record from the bucket, they would get an
that's all.
No, it's bucket deletion. It's equivalent to volume.
Yeah. So there is a GCS retention policy, which is different than the deletion policy of the bucket, which is more akin to the retention policy of the PV.
Yeah.
That's not showing here, right? See it?
Object locking is what Tim's talking about. If
he was talking about GCS retention policy, the fourth one on this, the fifth one on the right hand side of the slide, which is that's
GCS
distinct
called the
from
retention policy. Yeah.
That's distinct from the
But what
bucket
about the
deletion
other
policy, which is
But
do I
They
delete
call
the
it
whole
object
bucket or not?
locking. On AWS S3, it's called object locking, where you can't override an object or delete it once it's created, even if you have credentials for it.
So we don't need to map each feature to every other feature. The model of a PV, if we try to model this the same way we model a PV and PV claim, that's one path. Buckets are very different from PVs, though, right? Buckets often have public URLs, and so like there are things that you need to consider that aren't applicable to PV and PV claim. And I'm not an expert in this area, but I question whether they're really as easy to map as they seem like they would be.
So the core difference is, I would say, one is the fact that it doesn't talk to POSIX API. There are no edits. The other is it's consumed over the network. That's all is there to buckets, really.
No, I mean, hypothetically, like I won't say all the cloud provider bucket systems have a way of exposing a bucket publicly, right? There's this anonymous access thing. There is no equivalent for a volume. There's no way for me to take a file system mounted disk and say, hey, expose this to the internet and let anonymous people download stuff from it. I have to provide a server on top of it.
Mm-hmm.
Right. So there are some pretty fundamental differences there.
Well, so I would look at that as similar to like deployments and services, or services and load balancer services, or ingress. You create a bucket with anonymous access set to true, and when you want to expose it to the world, create an ingress controller that points to this bucket, or points to this bucket URL.
But you don't need an ingress controller. I mean, we could model it as an ingress controller, but you don't need an ingress controller to do that, right? Like I can just go to storage.googleapis.com and look at your anonymous buckets. I don't need something special to do that.
If you're using a public cloud provider, yes.
Right. So we may run out of time. We will run out of time. The questions that I have are really all about like, what is the role of Cozy and how are people going to use it? If you're saying that the purpose of Cozy is to grant arbitrary users within, I'm going to find out how to say this right, to grant users within a cluster access to buckets that they do not own, mm-hmm. even though they may have manifested the creation of it, they still don't own it. Mm-hmm. Then that's fine, and the API may be a better fit for that as it's currently spec'd. I'm personally skeptical about whether that's a useful boundary or not. Like I would not have been able to use that for the things that I had to use it.
Yeah, it goes back to that role of admin versus user. You would be an admin in a sense there, wouldn't you?
But I don't want to be an admin. I want to be a user, right? Like
So
it is in my mind, it's the paragon of Kubernetes and cloud native is self-service. And if we build a system here that is lacking the ability to do self-service, it feels like it's and this is again all about scoping, right? It feels like it's missing the point.
So we have a good story for greenfield style self-service where I just want to create the bucket and consume it and then delete it when I'm done with it. Are you saying that we don't have a good story for self-service for the brownfield use case of, hey, somebody else made this bucket and I just want to vend it into my namespace?
Well, I'm not even sure, like, even if you just look at greenfield, like let's just rule brownfield out for a second.
Okay.
Looking at the way greenfield is currently spec'd, there's at least one policy thing in the anonymous access, right? Which is set on the bucket, which I, as a user, can't self-service mutate, which is frustrating. I'm using a bucket, but I don't own it. And even though I caused it to come into creation, I don't own it. Specifically, the COSI spec, if I recall, said if you want multiple people to be able to use a bucket, you create multiple Kubernetes bucket resources, capital B buckets, pointing to the same cloud bucket. I'm just going to use those terms, or S3 bucket. And
we're calling that the brownfield.
Yeah. So now, in order for multiple people to use it, you have to go to the brownfield case.
But we could write a controller later that automates that process. That does what today an administrator would have to do to basically make copies of the bucket object and bind it to a namespace bucket request in a different namespace. Like that can all be automated with yet another controller.
Sure, but now you have a policy, at least one policy field on the bucket that in theory could be different across the two different Kubernetes buckets. And you now have to decide which one actually is reconciled to the S3 bucket and which ones are ignored, right? Like what stops me from creating two Kubernetes buckets that point to the same underlying bucket and setting different policies on them?
Yeah, so we just kind of talked about, we don't think anonymous access should be even a part of the spec as it is now. It needs to be taken out, made an opaque field. But to answer your question, what fields should be considered and what fields should be ignored, yeah, that becomes tricky.
I guess I have a question also. So I guess I'm coming from the perspective of like trying to integrate with this library in Rook and trying to consider what our users are going to be wanting to do. So in this case, there's also, if I am, let's say I have an application and I want to create a Helm chart library in a bucket, and I want this to be long-lived, and I want to be the only one who can write to it, but I want to allow anyone to freely read from it. Like, do I have the ability to set those kind of permissions? Like, can I say I don't want any other like Kubernetes users, like if I'm in a multi-tenant environment, to be able to claim my own bucket with write access? Or like, do I want them to be able to claim it, but only with read access?
Yeah, you can still do it by setting now we just said opaque policy. You can set granular policies based on whatever protocol it is through the bucket class. Yeah, but another question I have is, were you talking about provisioning buckets without, it's like an admin provisioning a bucket that will be later consumed by someone else, or maybe used even manually? Is that how you were thinking of this use case?
No, I guess I'm imagining that I am like a user in just some Kubernetes cluster, and this Kubernetes cluster has many users. I'm merely one tenant of many. And I, as part of my workload, I want to create a Helm chart library. And I think that is a case for, this is a thing that is long lived. Like, I don't ever want this to go away. I don't have the option of just saying, well, now I've deployed this, like I realize something's wrong, I'm just going to destroy it and recreate it. Like I need, if I do that, I need to migrate the contents of the bucket to the new bucket at minimum. But ideally, I think I probably have the same bucket, or at least like access to that bucket from the outside world needs to look the same. So I think that particular use case is an example of like why mutation might be good, and like the kind of like control that I think, and I'm certainly not an expert in this domain, but
I still don't get what you were mutating on that.
I think Tim had a good example of like a security audit. If suddenly you're like, oh, I want to change some parameter about this, or I have recently discovered, oh, I set this parameter wrong. This is in danger of being deleted if I mess something up. I want to like change the policy to be retain. I think just saying, these are for short-lived workloads and for buckets that get created and destroyed often. I think I see a lot of cases where there could be tenants of a Kubernetes cluster who don't want that, who want a long-lived bucket and who want to.
We're gonna allow that. It's not that we're not gonna allow it. It's just it'll be done by the admin.
I don't see why this is different than with volumes. I mean,
yeah.
If the same thing happened with volumes and you had some security audit that says, well, you forgot to set the security option on your volumes, like you just go fix that by going to the storage controller today. You wouldn't expect Kubernetes to be able to go fix your audit policy on your PVCs.
Well, I mean, actually, like if my time machine was working, I would probably go back in time and convince SOD not to implement persistent volumes as a non-namespaced resource, and instead make the whole thing namespaced, because the binding, the whole PVC binding stuff was very short-lived, and everybody moved to dynamic provisioning anyway, because it's better in pretty much every way. And so I would argue that the lack of self-service on PV is a counter indicator, not a pattern to be followed.
Well, the question you brought up earlier.
I was just wondering if Tim, actually you recommend we actually just have one CRD instead of two right now, because we have the bucket request and bucket. Do you recommend we just have like a bucket request instead that's namespace? We don't need this non-namespace?
So I'm not sure the answer to that. There's an ongoing discussion on SIG architecture that I kicked off largely in response to this conversation, but also this pattern that has been occurring over and over again, about whether we can treat status as sort of the trusted subset of fields that are allowed to write by controllers but not allowed by users, right? To do something here, you have a sort of request and grant pattern. PV claim models that, bucket request models that. The question that is open is, could we model that in a single resource with spec and status, or maybe something else in a trusted way? Because I think it would provide for simpler APIs. Like, wouldn't it be nice if there was just a single resource here that you created and as a request, and the controller filled in the status, and now you can use your bucket? It's unclear yet what the resolution to that discussion will be, which goes to the, like, should it be one resource or two? But the larger question here that I have that really nags at me is, should this be a namespaced, should bucket be a namespaced resource that indicates some form of ownership? Or if, it's your API, not mine, right? So I want to be really careful here, because at the end of the day, SIG storage has to deal with the ramifications of whatever design decisions are made. And so if we say like this is what it's for. This is the box, and if your use case doesn't fit in the box, then you don't use this API because it's not for you. Then that's fine. I'm not going to. I'll discuss whether the box is the right shape or not. But if you have use cases that indicate that that's the right box, then cool. I lost the train of where I was going with that. My point being that I don't want to try to dictate use cases that aren't realistic, but I do look at this from a user's point of view, and I find it limiting.
I just wanted to sort of mention that we've mirrored this PVC PV two-way bind with snapshots, and the question you raised about, what if I want to share my bucket across namespaces, is a problem that we already have in the snapshot world. I am writing a controller to enable people to take snapshots of volumes and then make replicas of those snapshots in other namespaces so other people can clone them. That runs into all of the same problems you're talking about, and that code is GA now. We just moved to GA in 120.
Yeah, I mean, we don't get to go back and re-adjudicate previous decisions, but we can try to do better and learn from our mistakes, right?
I will be very interested to if it turns out that the two object namespace non-namespace two-way bind is the wrong decision, then what we can possibly do about all the places where it's the decision we made, because I don't see the alternative working, but I haven't thought about it as much as you have.
I mean, even if it stayed as two resources, but it was two resources that had a clearer concept of ownership, it might be better. And to be clear, I hadn't thought about these snapshots use case, but it's just one more for this pattern, right? And I will say,
we use this pattern a lot.
Yeah, well, and I'll say, like, there's the other API that I've been involved with this year, which is the gateway design in SIG network, went in the other direction and said, look, we're not going to model this as a rooted resource. The whole stack is except classes, the whole stack is namespaced, and the people who create the gateways really do own them, and it really is designed to be self-service, but they have some delegation model that allows cross namespace linking to solve the brownfield cases. And it's a little early to be super confident in it, but it feels pretty good. And I just realized the time. I'm happy to keep going on this. What I don't want to do is like pigeon programming, right? Swoop in and take a crap all over everything. But I do want to encourage folks to think about the value of self-service. And if we decide that it's not valuable enough to accommodate, then that's an explicit decision that you can take, right?
What we should do is take a look at a counterexample of one that's been done, as you say, all within the namespace, all self-service, and take a very serious look and see, can it address all of our needs? Because I have this sneaking feeling that I can't put into words that there's something about our namespace, non-namespace, dual object model that there's a reason for it, that we would lose something valuable if we put everything in the namespace.
So one thing I can do, I mean, you can go off and do that. I would be happy to ask, in fact, I've already asked the networking folks if it came to it, would they be willing to show up at one of these meetings and just show you the gateway API and talk about how it could possibly map to this, if that's interesting.
That's interesting to me.
What's the status for that? Is that like alpha or?
It is alpha now, I believe. Or it will be alpha in, I mean, it's not in 21, but it's aligned with.
Okay.
So yeah, I'd be happy to have them show up if Saad or somebody wants to ping me afterwards. I can connect the dots.
Yep, will do.
And it might be a thought experiment that we do. We model it out and we say, you know what, Bucket doesn't hold as well as Tim thought, and like now that we thought about it, we're not going to do it. Right, that would be an acceptable answer to me.
Yeah, I think we should consider it once. I don't know entirely how it works, but it's definitely worth considering.
Yeah, we also have the working group volume group proposal right now is just like one object. So you can probably also take a look at that, the gateway model.
Okay. Yeah.
All right. Unfortunately, I have to drop off. Saad, catch up with me afterwards, and well, you know Bowie. You can just ping Bowie and Mark, and they've already offered to show you what they've been doing.
Yep, sounds good.
Perfect.
All right, and if we want to have a follow up then on this, I'm happy to attend again.
Yes.
Sorry
Same
for the
time
short.
next week if it works for you.
We'll be meeting
throw
on
it
Monday. Sorry.
Okay, I'll add it to your calendar.
Yeah, throw it on my calendar, and we'll see what we can do. Thanks all.
Thank you.
Thank you.
Thanks.
Thanks.
Yeah, I think we can conclude here. Talk to you all on Monday.
Sounds good.